Good morning, students. In this video lecture, we are going to discuss laws of refraction and the importance of refractive index in the reference of refraction. I hope you had gone through the previous lecture videos related to this topic, but this particular video is for class 10th and as well as for class 12th also, so that the students can understand the physical significance of refractive index. So first we should go through the laws of refraction. Okay. Laws of refraction. So it is a very basic fundamental phenomena which you had seen in daily basis. Okay. So whenever when a ray of light passes through any medium or it changes its medium, then it bends, or we can say deviate from its path, and this phenomena is called refraction. But this deviation has several outcomes. Okay. Suppose this is a normal on our refracting surface. This is a normal. This is a normal. This is refracting surface. This is our incident ray I. This is our incident ray, and this one is our refracted ray. Refracted ray. Now you can see that it never happens that always the refracted ray bends towards the normal. It may be also possible that ray can refract beyond the normal, because it depends on which medium to which medium rays is incidenting. For example, if we talk about some mediums, okay, suppose air, glass. So as we know that with respect to glass, air have the low density, because air, the intermolecular spacing in air is quite greater than the intermolecular spacing in glass. So air could be termed as rarer medium, while on the other hand glass can be termed as denser medium. But if we talk about water and glass, so again water have the rarer medium with respect to glass. But if we talk about air and water, then air will be the rarer medium and water will be the denser medium. So what is happening over here? It means it is not absolutely correct to being termed any medium permanently rarer or permanently denser, because it always depends on the comparison with respect to the other medium. कि किन्हीं भी दो मीडियम्स के बीच में जब हम कंपैरिजन करते हैं, only then we can decide that which medium can be termed as rarer and which medium can be termed as denser. So when our light comes from rarer medium to denser medium, it bends towards the normal. And if light comes from denser medium to rarer medium, it bends away from the normal. It bends away from the normal. So this fundamental phenomena is called refraction, and most importantly, refraction has two fundamental laws. First law is that incident ray, refracted ray, refracting surface and normal all lies on a same plane, and right now they are presenting on the plane of this board. And the angle of incidence means the angle between normal and incident ray, that is represented by angle I. Refracted angle, or we can say angle of refraction, that is the angle between normal and refracted ray, R. So the second law is that the sine of the angle of incident to that of sine of angle of refraction is always a constant quantity, which is called refractive index of first medium, refractive index of second medium with respect to 1. This is the fundamental quantity which is our point of interest in today's video. In today's video, our main purpose to make sure to understand that what is the physical significance of refractive index. Okay. So students, now we are going to discuss the physical significance of refractive index and how the refractive index plays the vital role in the refraction phenomena. So as far as we talk about refractive index, so let me tell you that refractive index is nothing but just a ratio of velocities. Okay. Suppose refractive index of medium, refractive index of any medium is equal to the velocity of light in vacuum to that of velocity of light in medium. So suppose the velocity of light in vacuum is represented by c. So refractive index of any medium m can be represented as velocity of light in vacuum c to that of velocity of light in medium, that is Vm. Now, if we are talking about, suppose air, if we talk it about water, if we talk about glass. So refractive index of air with refractive index of air will be the speed of light in vacuum to that of velocity of light in air. If we talk about the refractive index of water, then it is speed of light in vacuum to that of speed of light in water. And similarly, speed of for glass, speed of light in vacuum to that of speed of light in glass. So these are the formula for refractive index for different medium, for different media. Now, if we talk about in the case of refraction, so in case of refraction, we learned that when light travels from one medium to other medium, it means light changes its medium. So what happens when it changes the medium? So basically the medium when changes, the intermolecular spacing of different mediums are different with each other. So the velocity of light, or we can say the light ray suffers some kind of scattering, refraction and the collision with the intermolecular spacing and intermolecules of the medium, which may occur, which may result the change in velocity and wavelength, but always remember there will be a no change in the frequency. Okay, so let me tell you, suppose in our case of refraction, suppose this is medium 1 and this is medium 2 and light, and this is our normal, and light comes from first medium to second medium, then according to second law of refraction, which is also known as Snell's law, we can term as angle of incidence I, angle of refraction R, that is sin I by sin R equals to refractive index of second medium with respect to 1, which means refractive index of second medium with respect to 1, like this. Now, if we go through this particular equation, then you can see if you change the values, as you know that refractive index of any medium is actually the speed of light in vacuum with respect to the speed of light in that medium. It means this equation can also be written as sin I by sin R equals to mu 2 with respect to 1, which equals to mu 2 over mu 1 and equals to C upon V2 divided by C upon V1. C upon V2 divided by C upon V1, which results that sin I over sin R equals to refractive index of second with respect to 1, which is refractive index of second with respect to 1. The vacuum velocity will be cancelled out and we get the equation velocity in first medium with respect to the velocity of second medium. So this is the complete equations of the Snell's law can be written as like this. So this is the very vast analysis of refractive index which we had learned today. In next video lecture, we will learn about the principle of reversibility of the light. Okay. Till then, you can watch this particular video. If you like, then please like, comment and subscribe. If you have any type of query, then comment box में आप comment कीजिए. And yes, please subscribe the channel. Thank you. Peace out.